So, I'm Alex Fragmenti.
I'm Nick Zofka.
I'm Dave Luby.
I'm Brendan Ulrich.
And we worked on an Arduino light sensor. So we're going to break down kind of our thought process and everything that went into it. So
starting off, this is our diagram of how our sensor works. So we have a light going into the sensor, which processes a voltage over time and goes into the Arduino. The Arduino then displays, getting powered from the 9-volt battery, the lux rating on the LCD display. And we see a first order sensor output against time with the Arduino light sensor.
So then one idea we had was to use a potentiometer to vary the resistance so we could change the brightness on the display. We liked that idea, but then we wanted to have a less manual control with your hands. So we decided to try out incorporating resistors in parallel. That didn't end up working for us, so then we ended up programming inside the Arduino itself a control system, a bang-bang control system.
Our bang-bang control system is the current method that we're using, and it involved, instead of sending out separate voltages to each individual ports, we connected it to one port, which was a PWM port on the Arduino, and then we were able to, in the code, make it conditional so that if the lux reading fell within a certain range, we sent a certain frequency to the PWM signal, which then displayed on the LCD display. And if the range were to change between certain thresholds, it would change the frequency of the PWM signal, and then that would result in a different brightness of the LCD.
And to return to the analytical component of the project, we will be using either the serial monitor or potentially an oscilloscope to pick off the change in voltage of the sensor's output with respect to time. And then we're going to characterize the system as Nick said, a first order system, derive the time constant gain, steady state output, and the settling time. And we know that it is a first order system based on its documentation. So that concludes the overview of the Arduino light sensing LCD output team's project. And we thank you for watching.
Thank you very much.
Thank you.
Okay, so as you can see here, here's our setup. Go ahead and plug it in.
We're gonna add some power to the system here via a 9-volt battery.
It's on now.
You can see the sensors turning on and it's displaying a lux. So now our idea is to change the lux and adjust the brightness on it. As you can see now, the lux is increasing and the brightness is changing.
So that means the lux has increased past a certain threshold and triggered a new frequency on the PWM, which is what's causing the intensity of the display to change brightness.
And that's our project.